Today we are working on 2-1 some more. We're still talking about domain and range, but today we're doing it from graphs, and this is a little more difficult. So it's something that we will spend some time on throughout the year. We'll visit domain and range numerous times and just keep practicing it because it is a little bit harder than when you just had a list of ordered pairs. Okay, so first thing, you still need to remember that domain are your x's and that range are your y's. Okay, so that's still important. Since domain are your x's, you need to be thinking about the x-axis, which is left and right. So you want the farthest left and the farthest right spot on this graph. So as long as there's no arrows, and we're not going to look at graphs with arrows for a little while. As long as there's no arrows, there will be a farthest left and there will be a farthest right. So does everybody agree that this is the farthest left and this is the farthest right? So this is the farthest left spot on the graph and this is the farthest right. Well, I want to know their x values since I'm talking about domain. So my x value at the farthest left spot is -5 because that's where I cross the x-axis. Okay, my farthest right x has a what x value? Do you know? Your x value everywhere here is 0. And I've got all the points in between. So I put all the x's in between. So x goes in between -5 and 0. Now this is the part that confuses most students. So I'm going to explain it a few times and then I'll just let you know that this is how it always goes and we're just going to slap the signs down. So here when I'm at the -5, the smallest x, the farthest left x, the only way I can go is to the right. Well, whenever you go to the right, your x's get bigger. So I want to say my x's are getting bigger than -5. So I put the big mouth facing the x. But when I'm here at the farthest right, where my x is a 0, the only way I can go and be on the graph is to the left. Well, whenever I go to the left, my x's get smaller. So I want to say my x's are getting smaller than 0. So I need the pointed end facing the variable to say x's are less than 0. And then remember, closed circles get equal signs, but open circles do not. And that's my domain. So whenever we write the domain like this is called inequality notation. You always put the smaller number on the left, the bigger number on the right, and as long as you do that, your signs will always go like this. Okay, so now we are going to write this in interval notation. So I just did inequality notation because these are inequality symbols, and now I'm going to do interval. So my x's are just going from -5 to 0. So it's just going to be -5, 0. Because of the closed circle, it gets a bracket, but because of the open circle, it gets a parenthesis. And that's my domain. Okay, looking at my range are my y's. And so my y's are up and down because the y-axis is up and down. So now I'm looking for the lowest spot of the graph and I'm looking for the highest spot of the graph. And that's because the y-axis is running up and down, low to high. Okay, so this is my lowest point and this is my highest point. Well, my lowest point has what y value? What y value is this? -4. And I can draw lines like this. So my lowest y has a y value of -4. And my highest y has a y value of 5, because that's how high it is. And I've got all the y's in between. So I'm going to put y in between. Okay, so to explain this, when I'm down here at the lowest y value, at the -4, the only way I can go is up. Well, when you go up, your y's get bigger. So I want to say my y's are getting bigger than -4. So I have to put the big mouth facing the y. When I'm up here at the highest y, up here at the 5, the only way I can move and be on the graph is down. Well, when you move down, your y's get less. So I have to put the pointed end facing the y, so it says y's get less than 5. Okay, When I was down here at the -4, it was a closed circle, so that gets an equals. And then when I was up here at the 5, that was an open circle, so no equals. And that is inequality notation for range. Once again, smallest number on the left, biggest number on the right, and the symbols always go this way. So I was trying to explain how I know how they go, but most of the time students just start to memorize it. Okay, and then interval notation. The y's are just between -4 and 5. So it's just -4, 5. The -4 had the closed circle, so it gets the bracket, and 5 had the open circle, so it gets the parenthesis. Remember interval notation? It's always smallest number, biggest number, smallest number, biggest number. Okay, let's look at number 2. Like I said, domain and range, it's much harder when you're looking at a graph, so we will have to just practice this quite a bit. All right, so domain. I'm looking, remember, left and right. This is my farthest left spot on the graph, and my x value is a -5. And the farthest right spot on the graph is right here. Now you don't see a point drawn, but this is the farthest right spot of the graph. So we don't go to this one because the graph goes farther right than that. So I want to know the x value right here. And my x value right there is a 3. And I've got all the x's in between. So x goes in between. And I'm just going to slap down the symbols. Okay, at the -5, it's a closed circle, so it gets an equals. And then at the 3, if you do not see an open circle there, that means that it's closed. So it will also get an equals. And then interval notation is just going to be from the farthest left at -5 to the farthest right at 3. So it's -5, 3, and because they both had equal signs, they'll both have brackets. Okay, now looking at range. Range are your y's, so now we're looking lowest to highest. This is my lowest spot of the graph, and my y value there is -3. This is the highest spot of the graph, and my y value there is a +3. And I've got all the y's in between, so I write y in between. And then I'm just going to slap down my symbols. Okay, there's a closed circle at the -3, so give it an equals. There is a closed circle at the +3, so give it an equals. And then interval notation. The y's are just going from here to here, so it's just from -3 up to +3. So it's -3, 3. Because they both have equals, they both get brackets. Interval notation is pretty easy if you don't have any arrows for things to go on forever and ever to infinity. All right, hopefully that one was a little bit better than number 1. All right, remember, domain, we're looking at x's. So we're looking left and right, farthest left, farthest right. This is my farthest left spot on the graph, and who is the x value there? -3. This is my farthest right spot on the graph, and who is the x value there? +4. And I've got all the x's in between. So I put x in between. And I slap down my signs. Do you know who's going to get the equals? The -3 will get the equals because it's the closed circle. 4 is an open circle, so no equals. And then interval notation would then just be -3, 4. Who's going to get the bracket? -3 will get the bracket because it had the equals, but 4 gets the parentheses. Okay, range. These are y's, so now we're looking up and down. We're looking for the lowest spot on the graph and the highest spot. So here's my lowest spot, and I want to know its y value. So I come and I look at the y-axis, and this lowest spot has a y value of -5. Then I look for the highest spot of the graph, which happens to be up here, and that y value is a 3. And I have all the y's in between there. So I put y in between, slap down my signs. Down here at -5 is a closed circle, so it gets an equals. And up here at the highest spot, remember, if you do not see an open circle, it's understood for the graph to get to that spot, which means it's assumed to be a closed circle, so it will get an equals. And then interval notation will just be from the lowest spot, -5, to the highest spot, 3. So -5, comma 3. Because they both have equals, they'll both have brackets. Okay. I put several on here for us to practice because, like I said, this is typically hard for students. Some students think it's easy, but a lot of students do not. All right, domain. X's, left and right. This is my farthest left X, and that X value is 1, 2, 3, 4, a -4. My farthest right spot on the graph is right here, and it has an X value of 1, and all the X's in between. Slap down those signs, and then because they're both open circles, then there's no equal signs. Interval notation will just be -4, comma 1, and they'll both have parentheses because there are no equal signs, because there's no closed circles. Okay, range, we're looking at Y's. So we are looking up and down. We're looking for the lowest spot of the graph and the highest. This happens to be the lowest spot, and I know it doesn't quite look like it's touching the x-axis, but we're just going to assume that it is. So what is your y value right here when it's touching the x-axis? Your y value is 0 because you're not up any or down any, so your y is a 0. Now, granted, it looked like it might have been 0.1, but I didn't want to have to deal with numbers like that. So let's just assume that it touches the x-axis. Okay, and then the highest spot of the graph is way up here. And who's that y value? A 5. And it's all the y's in between. Slap down your signs. Okay, down here at the 0, because I do not see an open circle, we're going to assume it gets there, so we're going to give it an equals. But up here at the 5, it's an open circle, so no equals. And then interval notation would just be 0, comma 5. And who's going to get the bracket? The 0 will get the bracket because it had the equals, but the 5 will have the parenthesis. Okay, let's try one more of the domain range. Okay, domain once again, X's. We're looking left and right, because that's how the x-axis runs. Okay, the farthest left. Well, all these points are the farthest left points of this picture. So who is the x value at this spot? 1, 2, 3, -3. And then the farthest right spot of the graph, that's right here. And who's the x value at that spot? 1, 2, 3. Okay, and I've got all the x's in between there. Slap down your sign. Now you don't see any open circles at all. That means everything's assumed to be a closed circle. So we'll give them equal signs. And then interval notation would be -3, comma 3, both with brackets because they both had equal signs. Okay, range. These are your y's. The y-axis runs up and down, so you're looking for lowest and highest. Okay, so do you agree this is the lowest spot of the graph? Okay, who's the y value right there? The y value right there is -2. And then let's find the highest spot of the graph. And that's this guy. And who's your y value there? +4. And I've got all the y's in between. So we put y in between, slap down our symbols. Once again, because there's no open circles at all in this picture, then that means we assume that everything is closed, so they get equal signs. And interval notation would be -2, comma 4, and because they both have equal signs, they both get brackets. Okay, hopefully you're feeling a little bit better about domain and range. That's why I put so many on there, because I was hoping it would click at some point for you. All right, this next page talks about a function rule. Okay, so this is like an input-output machine. we are going to put something into the x, work it out, and it's going to spit something out. Okay, so like if I put an x value of 1 in here, then I would take 3 times 1, which is 3, and add 4 to it, and it would spit out a 7. But what if I put a 2 in? So if I put a 2 into the x, it'd be 3 times 2, which is 6, plus 4, and it would spit out a 10. So this is an input-output machine. You put something in and something comes out. Okay, well, sometimes it's not a y. Sometimes it's something that means the same thing, but it looks kind of funky. This over here is called function notation, and we read this f of x right here. F of x. So this is f of x, but it could have been g of x. It could have been h of a. So all of these are different ways of writing something in function notation, but the h of a, the f of x, the g of x, they're just a fancy way of writing a y, and it's called function notation. Okay, so this problem here, it gives me an f of x equation, and it asks me to find f of 5. Okay, so I'm going to write f of 5 down. So what I want you to notice is where the x was in the parentheses, now you see a 5. So what that's telling you to do is it's telling you to go to your f equation, and this is my f equation, but they're saying instead of using an x, use a 5. So that means everywhere I see an x, I'm going to put the 5 into it. Boop. So I'm going to recopy the 3. As soon as I see the x, I slap parentheses down, I plug the 5 into it, and I recopy the -5 in the back. Okay, so basically, instead of using an x, they're telling you to use a 5. So that means just put a 5 wherever you see the x. And then all I do is order of operations on this side. So remember, we're going to multiply before we subtract. So what's 3 times 5? 15. Recopy your -5. And what's 15 minus 5? 10. And that's your answer to f of 5. And you're done. Now, sometimes students think that you're solving for f, so they want to get rid of this 5 by dividing by it, but do not do that because we were asked to find f of 5, and that's exactly what we did. F of 5 equals 10. Yes, kitty, I know. I'm almost done. All right, this next one. They gave us an f of x equation, and they're asking us to find f of -3. Okay, so I'm going to write f of -3 down. So what this means is go to your f equation, and this is my f equation, but they're saying instead of using an x, use a -3. So I'm going to put -3 into this x, and I'm going to put -3 into this x. Since we had more than one x in the equation, we're going to plug -3 in more than once. Okay, so this -2, I recopy it. As soon as I see my variable, I slap my parentheses down. I plug in the -3. I recopy the squared. I recopy the -3. As soon as I see that x, I slap parentheses down. I plug the -3 into that x. And then I recopy the -1 in the very back. Okay, so all I'm doing is I'm putting -3 into this x and -3 into this x. And that's because the -3 is where the x was. So it's saying, hey, don't use x anymore, use -3 instead. Now I just need to do order of operations with what's on the right. So remember PEMDAS? Please excuse my dear Aunt Sally. First it says do what's in parentheses. Well, there's nothing to do in those parentheses. It's just a number. And there's nothing to do in those parentheses because it's just a number. So parentheses is out. So next, exponents. So that means I want to take -3 and square it. Well, -3 squared means to take -3 times -3. So this is telling you, the exponent is telling you to take whatever's in the parentheses times itself 2 times. And negative 3 times negative 3 is a positive 9. Now, because the negative 2 is smushed against the x, then that means this negative 2 needs to multiply with the 9. So I'm going to put parentheses back around it. I'm going to just recopy. Okay, if you ever look back up at the original problem, you know that these guys you're going to multiply together because they're smushed. And these guys you're going to multiply together because they're smushed. But you will not multiply this with this because it's not all smushed together. Okay, so we're multiplying these two together and we're multiplying these two together. So negative 2 times 9 is negative 18. Negative 3 times negative 3 is positive 9. And I recopy the minus 1. And now I'm just going to go left to right. So if I take negative 18 plus 9, that's negative 9. I'm going to recopy the minus 1. And negative 9 minus 1 is negative 10. And that's my answer to f of negative 3. And of course, I could always use a calculator to find that answer. It's just a lot of times students struggle plugging it in correctly. So I would type in negative 2, parentheses, negative 3, close the parentheses with the squared, minus 3, parentheses, put the negative 3 in there, close it up, and minus 1. So what students tend to struggle with the most is knowing what's a negative and what's a positive. So that's a negative, that's a negative, that's a negative. But this is a minus sign, and this is a minus sign. And if I hit enter, let's see, do I get the same answer? Negative 10? Da, 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 I did. Okay, so you have to be careful when you use the calculator, so that's something that we have to practice. All right, and let's try one more. All right, this next problem is asking me to find f of negative 2. So f of negative 2. So it's telling me go to your f equation, and this is my f equation, but instead of using an x, they want me to use negative 2. So I'm going to put negative 2 right there, boink, into that x. So I'm going to recopy the negative 3, recopy the parenthesis, recopy the 7, recopy the minus, slap parentheses down as soon as you see your variable, plug in what they told you to plug in, and reclose the parenthesis. Okay, I'm going to follow order of operations, and it says do what's in parentheses first. Well, there's nothing to do in those parentheses, but there is something to do in those parentheses. Do you remember a minus and negative back to back makes a big old plus sign? So what's 7 plus 2? 9. I'm going to put the parentheses back around it, and I'm going to drop the negative 3. And that's because I know because the negative 3 is smushed with this, that I need to multiply these. And negative 3 times 9 is negative 27. And that's my answer to f of negative 2. And that's it for this lesson. Smiley face.